Okay, this is Mr. Peterson, and we're going over page 2 of the 8.1 notes. We covered a little bit of how to find a base in the last little section. So we have a practical application problem here. In the year 2000, we have the population of the United States increasing at a rate of 1.24% per year. So we're going to find the growth factor, and that's code for the base. So the base is going to be 100% of the population plus a little bit extra each year, 1.24 more per year. And so when you combine those, you get 101.2 or 0.24%. So it's 101.24%. Now, percent means divide by 100, which moves your decimal to the left. So when you lose the percent sign, you move it to the left, and you get this decimal. So guys, that'll be the base that we're going to use here. All right, so what we're going to do here is show you another way to come up with that when you get to this point right here. So if you type 101.24, you hit the per sign, it's a divide. Latin per means divide. And then Latin cent means 100. So percent just literally means divide by 100. And it slides your decimal over 2 spots to the left. So when you lose the percent sign, it goes to the left. When you restore the percent sign, it'll go to the right, 2 spots both times. Okay, so there's your base. All right, now we got to find the initial population of the United States. At the beginning of this chart, which is the year 2000, there were 281 million people in the United States. So that'll be the y-intercept. 250, 60, 70, 81. That's the value of A. And we're going to put the millions back on it later, but it represents millions. This is also called the initial value besides being the y-intercept. Initial or starting value. So it's growing, starting at that amount. So we want to find out how long we want to graph this function here. Okay, so y equals ab to the x. We found the b value up there, and we know a is the starting value of 281. So this is going to be like this. 281, which stands for 281 million. 1.0124, and we have that exponent up there, which makes it an exponential function. All right, now we have to graph this. So let me first of all type this on the y equals line. I'll go to the y equals line and type in 281 starting value. A base that's bigger than 1, this will grow. Exponential functions have an exponent for the x. So hit the exponent key, it's right here. And then hit the X key. All right, now we need to set the window so that it matches what we have here. So I'm going to hit window, and this one has a minimum of -2 on the x-axis and a maximum of 17. So that's 17 years after the year 2000 is how you think about that. And then the minimum population on this graph here is about 240,000. And then it goes all the way up to 360, 70, 80, about 385 would be close enough. Now hit graph, and you're going to see this thing rising. That's the population growing at a rate of 1.24% per year. All right, since the base is bigger than 1, we're not surprised by exponential growth. Now I'm going to just plot a few points here. I'm going to go every third value. So I'm going to go trace 0, enter, and we already have that one down. 3, enter, and that takes me about to 292 million. So it'll be about right there. I'll go to 6. I'm just doing every third one here. That's going to take me to 303, approximately 303 million. And 9 years after the year 2000, that'd be 2009, we get 314, 10, 314 is right there. 3 years after that, I typed in 12, you get 325, almost 326. And then I'm going to go 15, that's 3 years after that, 338. So let's see here, there's 300, 10, 20, 30, 38, that's about right there. And then I'll just do one right over here, right against the edge, 17. And that's 347, approximately. So just shy of 350. So here's the graph that represents the increasing population in the United States. Growing exponentially, by the way. Okay, so it does ask us here, use the model to predict the 2015 population. Well, if your starting year is 2000, then 2015 is represented by x equals 15. So I'm going to hit the trace key again. I didn't probably have to, but then I'll say 15, enter, and it turns out to be 338. Now you have to make sure that that's millions. So we would expect in 2015 that there was 338 million people living in the United States. Okay, now we're going to shift gears quite radically. We're going to find the equation that goes through these 2 points, the exponential equation that goes through these 2 points. So we're going to start with this first one here. We're going to use a 2 for the x and a 4 for the y. The formula is y equals ab to the x. So if you plug those numbers in, you get this. Y equals ab to the x. And you can see I plugged these numbers in. Now I'm going to do it again over here with the other pair. Y equals ab to the x. And now that you have it set up like this, you're going to take the one that has a smaller exponent and divide it into the other one. So on this left side, if you simplify 256 divided by 4, you get 64. On the right side, the a's cancel, which is why I did it. And b to the 5th over b to the 2nd is b to the 3rd. So we're going to cube root both sides here to get our answer for b. The base here is the cube root of 64, which is 4. Okay, now you leverage that new piece of information in one of the 2 equations. I usually use the one that has simpler numbers. You know what the base is at this point. It's 4. We found that out earlier. 4 squared is 16. Divide both sides by 16. And you get an a value of 1/4. So now you come up here and fill in the a and the b into the original equation. So it's y equals 1/4 for a, 4 for the b, to the x power, and you've got your equation. Now we're going to check it by graphing it and seeing if these points are actually on the graph. So go to your y equals key, clear out what was there. Type in 1/4, I'm using 0.25, times 4 for the base. You want to hit your exponent key and your x, and then say zoom 6. And here comes the graph. Now touch the trace key and hit 2, enter, and you'll see that 2, 4 worked out just fine. 2, 4. And then 5, enter, and you're going to see 256 is also on the graph. So we have confirmation that that's the right answer. Okay, we're going to do it again with some less than convenient numbers here. 238. So the y equals ab to the x. And then I do it again with the other numbers. The y equals a to the x. You put the one with a smaller exponent underneath the other one. This side over here simplifies 0.819. That's the best you can do with that. Over here the a's cancel and you subtract exponents, fourth power. So now we're going to take the fourth root of both sides. Normally I'd put a plus or minus in front of this, but the base is positive, so we don't have to worry about that. And you get the base is equal to, let's see what we get when we type this in. So quit to the home screen. Type in 4, math 5, that's how you get the fourth root there. 4 math 5. And then type 8 divided by 19. Now on paper we're going to round this to 0.806, but we will use this more accurate version later. Okay? So 0.806. Alright, now we're going to come up here and rewrite this one with that new piece of information. Alright, so let's see what we get when you take 0.806 squared. And I'm actually not going to do that. I'm going to take this full version of the answer and square that. So I'm rounding on paper only. It's going to be 0.6489. And now I'll divide that into 38. And that tells me A will be, let's see what 38 divided by that last answer is. I'll go up and grab it. 0.58562, or excuse me, 58.562. And that's we rounded. So now I'm going to put the A and the B into the equation, which is y equals AB to the x. A, B to the x. Okay, there's your equation. We're going to check it and see if it gives at least really close to those points. So we'll go to the y equals key and type in 58.562 times 0.806 raised to the x. Zoom 6 to get the graph going here. And as soon as this settles down, we don't see much of it, but that's okay. It's up there. We're going to hit trace and 2, and hopefully it gives 38. Pretty close. Yeah, that's good. That's really good. And then we're going to go 6, and it should give something very close to 16, which it does. Okay, so that does it for page 2 of the notes, and I'll see you on the other side in the next video for page 3.